Hello everyone, we are discussing YDSE. Note down this question. The question is, this source is emitting a wavelength of 4000 angstroms. And when it emits 4000 angstroms, what we found that at a given point on the screen, third order maxima third order means third bright fringe forms. Now the question is, if this source is replaced with a different source of 6000 angstroms, then at the same place you need to find order of the maxima. Write down the question. A source of 4000 angstroms forms third order maxima at a given point on the screen. At a given point on the screen. Find out order of the maxima. Find out order of the maxima at the same point if source is replaced with another source of 6000 angstroms. Well, technically this question should not take more than 10 seconds, but I'm giving you 30, 40, 50 seconds. Let's see if you can answer this. Well, no response. Question says, at this point with 4000 you get third order maxima. Maxima means what? Bright fringe. This point means it has some distance x. Now this is x, and at p you're getting a bright fringe. Then what is the formula for x? For the bright fringe, x is n lambda capital D upon small d. This is the first thing which you need to think when a question like this is asked. They are looking for maxima, and therefore immediately write down the formula for bright fringe. So this is your x, which is n lambda capital D upon small d. Now you are changing what? Lambda. You're changing what? N. You're not changing x, d, and small d. Same separation between S1 and S2. So you're not changing d. You're not changing capital D. At the same point, that means you're also not changing x, which means n lambda is a constant for this question. Which means what? What is n? 3. Lambda 1, 4000. So we can write this as 3 into 4000. What is lambda 2? 6000. And we need n for this. So your n is coming 2. At this point, for 4000, you get third maxima. But the same point, for 6000, you will get second maxima, second order maxima or second right fringe. If you understand the calculation part, then write down yes in the comment box. Write down second question. Same profile at a given point with lambda 1, which is 3900 angstroms. You got fifth dark fringe. With lambda 1, 3900, you get fifth dark fringe. If I replace source with lambda 2, which is 6500, then what will be the order of dark fringe at the same place? Answer this fast. At this point, when source is emitting 3900, you found that fifth dark fringe forms. If you change the frequency and therefore wavelength from 39 to 65, at the same place, you need to find order of the minima or dark fringe. Not a single answer. Take the hint. I'm talking about dark fringe. Use the formula of dark fringe and you will get the answer. And if you don't remember the formula for dark fringe, it is 2n minus 1 lambda capital D upon 2d. That's the formula for dark fringe. Again, you've got same x, same capital D, 2 and D. And therefore, we'll say that 2n minus 1 lambda is a constant. If 2n minus 1 lambda is a constant, then fifth dark fringe means 2 into 5, 10 minus 1, 9. Lambda, which is 3900. For the second one, you need to find n. 2n minus 1. Lambda is 6500. So your 2n minus 1 is coming 5 to 10 minus 1, 9 into 3 divided by 5. 13, 3, 13, 5. 27, 5. 2n is coming 27 divided by 5 plus 1. And your n is coming 32 divided by 10, which is 3.2. Well, I've taken the data randomly and therefore you're not getting an integer, but you understand the profile, the way these things should be answered. If you choose values correctly, then this n should be an integer, because we'll say that third order maxima, things like that. But approximately we can say that it's a third maxima, third minima, which is getting formed at that point where you see fifth dark fringe of 3900 angstroms. Some of you could answer this. Rest, put down this part. Now note down next question. Next question is, write down the question. A source emits two wavelengths, 3900 and 6500. Let's take these same values. A source emits two wavelengths, 3900 and 6500 angstroms. Separation between the slits is d, small d, and separation between screen and slits is capital D. Separation between screen and slits is capital D. Find out position of the first minima on the screen. Position of the first minima on the screen. This question will also explain why in interference we must have single frequency. What happens if source emits multiple frequencies? It will be clear with the help of this example. In these previous questions, source was emitting first 3900 and then you replaced it with a source of 6500. This time same source is emitting 3900 and 6500 and you need to find position of first minima, the place where you will see dark fringe. Try to understand the question. Suppose there is a point P, and at P you found that for red maxima forms at P. If you use red color, then at P you found maxima. But if you use blue, you found minima. If source emits red, you get maxima. If source emits blue, you get minima. Now, answer this part first. If source emits both red and blue, then at point P, what will you observe? Answer this fast. Well, I'm asking you something which is very elementary. There is no catch in this question. Things are very easy. The first response is mix. Any other answer? Second response is dark fringe. Third response is combination of red and blue. Now understand the question again. What did I say? I said that at point P, if the source emits red color, you will find maxima. What will be the color of that maxima? Red. This is something which we discussed in the previous lecture. Bright fringe means, what is the color of bright fringe? Color of bright fringe is that color which is being sent by the source. So when I say red maxima, that means at this place you will see red color. If I use blue, then I've been told that minima or dark fringe of blue forms at P. What is dark? Dark means absence of blue. For blue, S1 and S2 will cancel out each other's electric field. That means no blue is present. The question was, there is a spot on the screen where red is present and blue is not present. So what do you see? You will see red color at that place. So in this profile at P, you are going to see what? Red color. Minima means no blue. And maybe some of you thought that minima means dark, dark means black. So some of you tried to mix red with black. Maybe therefore you asked mix or something like that. But in this case, what is happening? Red is present, blue is not present. So what do you see? Red. Now similarly, if at some place you found that maximum of blue takes place, minimum of red, then you will find blue color at that place. And if at some other place both red and blue are forming their maximas, at some other point it is a maxima for red, it's a maxima for blue as well, then it will be a mix combination of red and blue at that point. So now, who can tell me what should I do? You don't have to write the calculation part, just tell me how to handle this question, what should be done so that we get first dark fringe. Who can answer this? Well, no correct response. If I say that at this place dark fringe of blue is forming but bright fringe of red is present, then is this place completely dark? Answer is no. So what should be done so that you find a completely dark spot? If at a given point for both colors, if the respective minimas, the respective dark fringes are present, then that place will be completely dark. Suppose at this point P, minima of red takes place. That means red is not coming. It will be completely dark. Similarly, blue. For blue also, this is what? Completely dark. That means blue is not reaching, red is not reaching. This place will be what? Completely dark. If one of these color reaches a point, then that color will be present. If both are reaching the point, then both will be present. So, how do you find a complete dark fringe? Both these wavelengths should form their respective minimas at this point. Then only this place will be completely dark. If you understand this concept, then write down yes in the comment box. Good. Write down this point. For a completely dark spot on the screen, both wavelengths should form their respective minimas. For a completely dark spot on the screen, both wavelengths should form their respective minimas. Now working on the question is same. You're saying that at a given position, both wavelengths are forming their respective minimas. You are keeping capital D and small d same, which means 2n minus 1 lambda is again a constant. And if 2n minus 1 lambda is a constant, then look, 2 n1 minus 1 lambda 1 is 2 n2 minus 1 lambda 2. What is it? For lambda 1, you are getting n1th dark fringe at this point. Similarly, for lambda 2, order is what? n2 of the dark fringe. It's the same spot, same x, same capital D, same small d. This is 2n1 minus 1 divided by 2n2 minus 1, which is coming as lambda 2 divided by lambda 1. Lambda 2 is 6500 divided by 3900, which gives us 5 divided by 3. This is coming what? 5 divided by 3. Now what? This is coming 5 divided by 3. It means what? 2n1 minus 1. If I take it as what? 5. Then 2n2 minus 1, I can take it as what? 3. If this is 5, this is 3, then n1 is coming 6 divided by 2, 3. n2 is coming 4 divided by 2, 2. What is this? It tells you that for lambda 1 at P, third dark fringe is present, and similarly for lambda 2 at the same spot, second dark fringe is present. So both are forming their respective dark fringes, third and second. Means both colors are not present at this place. If both are not present, then this place will be what? Completely dark. We need to find x. What is x? 2n minus 1 lambda d upon 2d. What is the value of 2n minus 1 coming? 2n minus 1, if you are taking lambda 1, 2n minus 1 is what? 5. Lambda 1 is 3900 into capital D upon 2d. 2n minus 1 we have taken as 5. This is n1 and therefore lambda 1. If you want to write 2n minus 1 as 3, there is no issue. If you want to write 2n minus 1 as 3, then this is n2, this is 6500 into capital D upon 2d. Both are same things. 539, 365, they both are same. So this is the first place where both colors are going to form their minimas. So if I ask you what is the second position of the dark fringe, this is coming 5 by 3. Next I can take it as 10 by 6. This is 5 by 3. This is 10 by 6. Next I can take it as what? 15 by 9. But problem is I cannot choose this 10 by 6, which is shown in blue. And you know why? Who can tell me why I cannot choose 10 by 6? I can choose 5 by 3, I can take 15 by 9, but I cannot take this ratio as 10 by 6. Note down this much, and if you can answer this part, why we cannot choose 10 by 6, then mention this thing in the comment box. Good. Two n minus 1, it's what? Odd divided by an odd number. Odd upon odd. If I take 2n1 minus 1, if I take it as 10, then 2n1 minus 1, it cannot be an even number. Which means 2n1 minus 1 is 5, then it is 15. And if it is 15, then this is 15 plus 1, 16 divided by 2, 8. Similarly, this is 3, 15, 9. 2 and 2 minus 1 should be what? 9. 9 plus 1, 10 divided by 2, 5. Which means what? Next time after P, you will find a place where for lambda 1, 8th dark fringe forms, for lambda 2, 5th dark fringe forms. That means both are producing their respective minima at the same place, and therefore that place will be again completely dark. Now before this number 8, there were 4, 5, 6, 7, all these orders of minimas for lambda 1. But what was the problem there? This was forming dark, but this was forming bright fringes, and therefore that place was not completely dark. How do you find a completely dark place? Well, they both form their respective minimas. So when lambda 1 sends third dark fringe, lambda 2 sends second dark fringe, you get first complete dark fringe on the screen. Next time take 2n1 minus 1 as 15, and you will find put it in this formula, and you will find second completely dark spot on the screen. And this is the reason in interference we use a source which emits a single frequency, which emits a single wavelength, because otherwise you will find that some places are dark, some places are bright, some places are mixed. If I convert this source into a white source, it is sending all the wavelengths. If it sends all the wavelengths, then what will happen? At any given point, one color is getting its minima, others, they may get their maximas with different intensities, and therefore you will not find a completely bright or a completely dark spot. Instead, you will find that on an average, the entire screen is white. That's the reason source should be of single frequency. If you understand this whole question, then write down yes in the comment box. Write down this point. If in YDSE, a source emits white color, a source emits white color, white means all, complete vigour is present, then at any point on the screen, some colors will be forming their maximas. These maximas may have different intensities. Some colors will be forming their maximas and some their minimas, and therefore a complete sharp interference pattern will not be visible. Because of this, we always use a source which emits only a single frequency. We use a source which emits only a single frequency. Let's see how many of you will answer this part. We have a mirror. It's a mirror. Plain mirror. This is a source. And this is 2 millimeter. This is 5 centimeter. Length of mirror is 90. And at a distance of 5, we have a screen. Source is about 2 millimeter at a distance of 5 from the left edge of the mirror. You're holding a mirror, plain mirror like this. The source is emitting a wavelength of 4,000 angstroms. find out beta. What is beta? Fringe width. And what is the formula for beta? Lambda capital D upon small d. What is lambda? 4000 into 10 to the power minus 10. You need to find capital D and small d. What is small d? Separation between the slits S1 and S2. Or more precisely, separation between two coherent sources. So do you see coherent sources in this? There are no slits present. You have a screen, you have a mirror, and then after the mirror you have a screen. And only one source is present. There are no slits, no holes anywhere. Well, how many of you see the other coherent source? Well, you're trying to answer, and we are very close but not that close. You're saying that mirror is the other coherent partner. It is creating the other coherent partner. This is source, and I hope you know that at this place behind the mirror is S dash. What is S dash? Image. What is S? Object. So basically S dash is what? S dash and S, they are what? Exactly same. Exactly same means, if you remember the way coherence was created, if you remember that lecture, if S emits blue, then S1 and S2 they receive blue. If S emits black, then S1 and S2 receive black. So this S and this S dash, they are always what? Coherent. And since they are coherent, if this is emitting black, S dash is what? Image of S only. And therefore S and S dash, they become what? Two coherent sources. And simple concept of reflection tells you that if this is 2 millimeter, then this is also what? 2 millimeter. So this S acts as S1, this S dash acts as S2. What is separation between these two? 2 plus 2, 4 millimeter. This is 4 into 10 to the power minus 3 multiplied by capital D. What is capital D? Separation between slits and the screen. This is the slit S1, S2. And what is this separation? 595, 100 centimeter. That is 100 into 10 to the power minus 2 meters. That's the answer. That's how we handle questions like these. Requirement was to produce two coherent sources. So instead of sending light to S1 and S2, we have created two coherent sources by introducing a plane mirror. Note down this. What basically is happening in this setup is something like this. Look here. Any point on the screen, say this point P, will receive a light ray directly. At the same time, at the same time, this point P gets a second ray which gets reflected at this place. So as dash is what? Basically the concept. Nothing is present over here. It's a virtual image. What basically is happening, light is going straight, second ray is coming this way, and then a reflection takes place. So this ray is fundamentally coming from S only, and therefore both these rays, they are what? Coherent, and interference between these two take place at point P, which is giving us this fringe width. Now, for competitive examinations, we can add one more important part, next important part, especially for this mirror type of thing. Hopefully you remember from 11 that when reflection takes place from a denser surface, phase difference of pi appears in the reflected wave. In waves, go and see standing waves. In standing waves, when reflection takes place from rigid end, when reflection takes place from free end, these things were discussed. For now, remember this, light is coming from air. This is glass, a denser surface, reflection takes place, and because of that reflection, this reflected wave has an optical phase difference of pi. Optical. And because of this optical phase difference, I'll show you what this optical basically is. At point P, if you think that path difference is lambda, if you think that path difference is lambda, for a path difference of lambda, we normally say bright fringe forms, but this additional pi will make sure that it becomes a dark fringe. Let me show you this thing and it will clear the concept of geometrical and optical path differences. Look, this is a mirror. A light wave reaches point P like this. This is your source. Next time something like this happens, just for your understanding, I have drawn same number of waves. The thing is up, down, up, down, up, down, up, down, up, down, up, down. So normally we would say that a bright fringe is going to form. Both are supporting each other. Down, down, up, up. That type of thing is present at P. So normally you would expect a bright fringe. But in this case, you will not. The reason is, the moment reflection takes place at the denser interface from rarer to denser, this happens. If you can see the blue color, let me make it thick so that you can see it. This example will clear the concept of geometrical and optical. I hope you can see the blue, which is looking quite dark also. So normally we expected this black wave to continue at point P. But what happened? At the reflection, a phase difference of pi, develops in the reflected wave. So instead of receiving black, you start receiving blue. And now what? S is sending black, S is sending this black, and S dash, the image part, is sending blue. Between blue and black, you can see that they are cancelling each other, and therefore dark fringe will form at P. So if you look at this particular figure, then the way I have drawn it is this: 1 lambda by 2, 2 lambda by 2, 3 lambda by 2, 4, 5, 6. From S to P it is 6. From this, the path length is what? 1, 2, 3, 4, 5, 6. Somehow I have drawn both what? 6 lambda by 2. So normal geometrical part was what? This way, length is 6 into lambda by 2. 1, 2, 3, 4, 5, 6. This way, length is 1, 2, 3, 4, 5, 6. 6 lambda by 2. Which makes path difference what? 0. If path difference is 0, you expect what? Bright. But what happened? Because of this optical phase difference of pi, things are totally different now. Instead of getting a 0 phase difference, you are getting a phase difference of pi. And that pi is creating what? Dark fringe. This is cancelling this. This is the concept of geometrical path difference or phase difference and optical phase difference. So in any question, we always look for sum of geometrical and optical. If no reflection of this type is present, then it's always what? Geometrical. Geometrically, lengthwise. This part is called an optical phase difference. So this pi you see is called an optical phase difference. And because of this introduction of pi at P, you are getting a dark fringe. Again, what is the meaning of optical and geometrical? Fast. This is 0 phase. Pi 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. So this becomes 6 pi. 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. If you look at this path, again the same thing. 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. That's what you thought. But then things are quite different. 0, pi, 2 pi, and this is not 3 pi. You have got an additional phase difference of pi. This is 0, pi, 2 pi. Instead of 3 pi, you're going to say 4 pi, 5 pi, 6 pi, 7 pi, and therefore with blue you're getting 7 pi. Again, 0, pi, 2 pi, this is not 3 pi, this is 4 pi because of the introduction of this pi. 4, 5, 6, 7. And what is the phase difference? 7 minus 6, which is pi. If total phase difference is pi, you know, pi means what? E1 and E2 electric fields are cancelling each other, and therefore you're getting what? A dark spot on the screen. If you understand meaning of geometrical and optical with the help of this example, then write down yes in the comment box. Draw each and everything exactly in this form, and then you can leave. Thank you very much. This is geometrical. This is optical. Note down this much.